Welcome to Designing AI-driven Personalized and Adaptive Learning Environments course. In this video, we'll talk about open learner models. In last few videos, we talked about pedagogy module. We have to give a control feedback. We have to provide hint. We have to provide, the different kind of content, remedial content, when to intervene, everything. But the idea is that tutoring is not just providing, making the student do the math problem, right? It is about making student to learn how to learn. Instead of providing feedback, if you spoon feed all the time, if you do too much of personalized, student will lose it. So there's an issue of over tutoring risk could occur. So instead of that, the modern pedagogy, that is modern in the sense the recent last 20 years pedagogy talks about, instead of going to the more scaffolding or more hints, it goes to the open-ended models. They try to teach metacognition or self-regulated learning. Self-regulating is a bigger construct. In that, metacognition is one part of it. Metacognition affect, metacognition affect, motivation, and cognition also part of it. So what is metacognition? Metacognition is thinking about your own thinking, or cognition of cognition, meta of cognition. In SRL theory, metacognition is a cyclic process, or SRL is cyclic processes of planning, monitoring, reflecting. We talked about SRL metacognition in very first week. The metacognition is about, if I go for Flavel's theory, given any problem, I will first plan. You would be doing it, but without aware that you are planning it. First, I would plan. What should I do, and can I do it? Then you just plan. Then you would just plan. Then you just start doing the problem, execute the problem. While doing, you monitor. You are doing some certain of actions. You monitor the backend, am I going correctly? You are observing each and every small outcomes from your process, and you are monitoring metacognitively. If you are the proper metacognitive awareness, it is not that everybody who monitors will have awareness to find where is the mistake. But the people who have a metacognitive awareness, metacognitive knowledge, they would say, okay, I think I'm making mistake. This mistake continues, I don't think the system will work. I need to stop here. Metacognitive awareness comes up, and you kick and you take that up and reevaluate, evaluate. In the sense you evaluate against certain things, then you test whether it will work, why it will not work, think about all these things, then reflect. Okay, so this is about plan, monitor, awareness, evaluate, and reflect. These are the Flavel's 5 set of cyclical processes of metacognition. So here, a student giving feedback immediately saying that you did the math problem correct, and can you do it? Instead, can we teach the student how to arrange their thoughts metacognitively, how to do the self-regulated learning? If we arrange that properly, then we could able to provide the teaching better. We will make the independent learner instead of spoon feeding and making the learner depending on some system. Okay, so systems like MetaTutor and MetaGuru are explicitly designed to prompt these behaviors. It's the MetaTutor especially. Before you start the problem, hey, you want to, what is your plan? What are you want to start with? What is your learning goal? Select the 3 topics. And the different tutors in the system will try to say you are not reading properly. It's plan, strategizing, all these things would come into picture. We'll talk about this system in detail later. But the idea is that pedagogy module is not just rule-based system where the feedback is given based on learner's performance. We could also go beyond that. That's the idea. The other one is open learner models. The open learner models are, kind of like reverse the culture. For example, indirectly the learner models are hidden in the system. Student is give feedback. Instead, let the student decide their own path. So here the open learner model exposes the data directly to the students. The AI data and all the data you collected, all the understanding you created. For example, the prompt would show that my data shows that you have 40% mastery in the geometry. Do you agree with this assessment? If yes, it will give you a set of comments. You decide what to do. If no, you don't agree, you can take a test and prove yourself not agree. That kind of detail can be provided. So open learner model is that the learner model is open-ended and it gives all the data it collects and gives to learner. Let the learner decides pedagogically. So learner learns, self-regulates its own learning. Okay, here the system only provides the learners what are the learner models doing. Instead of pedagogical modules gone, we're giving it to data to these learners. That's another good approach. There's another approach which is very recent. Professor Manu Kapoor is talking about it, and a lot of people are talking about it, not just one. Based on the existing research knowledge, struggling with the problem before receiving instruction leads to deeper conceptual understanding. So don't intervene when they struggle. But how long you will let the student to struggle? We need to understand what is the threshold between let them struggle or when and they lead to frustration, they might drop out. So when to do that is a very important problem. So struggling is a good in learning. For example, if a student getting frustrated or confused, not necessarily bad, it is perfectly all right. A student needs confused in a new problem, then only they get confused and they're trying something, they're not achieving the expected target, they might get frustrated, perfectly all right. Let them struggle, let them do it, and by doing that they learn something new. If the student feels always in flow space, delight, is doing, enjoying doing it, is not having any confusion, any struggle, which means they are not learning anything new. They are in the comfort zone and bubble. So the struggling is actually good, but the system should know how long. So they're saying that don't intervene at immediate, let them go through it, then give feedback. That is the new logic as coming in. There's one more open-ended logic I want to talk about it. Till now we talked about math system, well structured, we know the topics, we know where the mistakes can make, we can deal with the rule-based systems, you can get the rule-based logics in the PED module. Non-constraint system like computer programming, we can use constraint-based logic. I think we saw this both in the initial. Here input known, input, steps and output. I know the steps a student has to make it, I know the steps student has to do input, and what is the output also I know. Exactly only one kind of output is possible. This is the math problem. Here known is input in a computer program, I know I give a set of input and I also have the output. I will give a set of conditions to test your program. If it works, it's correct. But the steps is not a fixed, it can be different. The fixed is kind of a known and fixed, fixed steps. Here the step is fixed. The way to achieve this is not the same in the computer programming. Think about the problem where there is input is known, but different output is possible. Like creating a logo design, art, designing something, creating, composing music, writing an essay, all these are creative things. What kind of pedagogical logic we could use? We could not use the rule-based system or the constraint-based systems. Here you could use the open-ended models like, hey, you are doing this, or you can test across established guidelines only. We cannot give a feedback. Okay. So I hope it is clear. We could have a pedagogical logic which is very structured rule-based system, or we could go for the content-based filtering or recommendation based on your peers or your preferences. It's also good. Or we suggest a recent modern learning science topics, metacognition and SRL, where we talk about let the learner to learn, we teach them how to learn instead of teaching the content. That's also possible. Next few videos we will see some of the examples of PED logic from the existing literature. A lot of papers we have read, and we kind of synthesized all those PED logic and created one particular set of videos for the next few weeks. Thank you.